Hello, hello, good afternoon. So today we'll discuss on accelerating AI vision trends on OpenShift. So I think all of you are using generative AI in your everyday life, and Gen AI is everywhere. But why Gen AI? So the research has done a lot of work, but also Gen AI arrived because of accelerators, because of compute capacities. And we are really lucky today to have on stage the three key silicon vendors, AI chip makers, so Intel, NVIDIA, and AMD. So I'm Erwan Gallen, OpenShift product manager, taking care of accelerator for OpenShift. And on stage, we have Raghu Moorthy from Intel, who is a global director taking care of product management for Red Hat hybrid clouds. We have Tetelman, who is a principal product architect, so you have two roles. And Ramine, Roane, who is the corporate VP of AI product management in AMD. And Adam is from NVIDIA. So with OpenShift, so in the market, we have a lot of accelerators, but with OpenShift, we are collaborating with these vendors to build and provide easily the access to accelerator for OpenShift for AI. And for this, it's not only providing drivers, but it's a full stack, starting at the Linux level with RHEL, after at the platform level with OpenShift Kubernetes, and also at the application level. So Red Hat has OpenShift AI. So my first question will be for you, Adam. So we are collaborating together for a long time. And how the OpenShift user can consume your GPUs, and also what are your current work with OpenShift? No, I don't think.
Is it on? There we go. Yeah, so I think at NVIDIA we think of AI and the consumption of AI in much the same way. It's not just one application or one platform. It's a full stack. So we're involved with software all the way down from the hardware up to the application layer. And of course, this means your basic Red Hat operating support, but we're also doing a lot of open source development. And I oversee a lot of the Kubernetes and cloud native development at NVIDIA. We've worked closely with Intel, with DRA. It's a new way to consume devices, and we've defined the standards for that. And we work really closely with Red Hat to make sure that that works in OpenShift. So in the open source, as we're developing these new features to better consume accelerators, we make sure that those features are consumable in the OpenShift platform. One of the biggest ways we do this is with our GPU operator. And so this is the sort of open source tool. It's available for all Kubernetes distros that we've gotten a lot of feedback over the past 2-3 years from Red Hat to define it, to make it better, and we've daily CI jobs to make sure it works full stack. And that's sort of platform level enablement. And a lot of that happens fully in the open source. But recently there's been a lot of move into the application level. We see things like accelerated software in deep learning frameworks, in inference, and we just announced NVIDIA NIM at our conference a few weeks ago, and one of the really exciting things working with Red Hat on this was integrating that directly in OpenShift. So it's no longer just GPUs and accelerators enabled through the platform, but all the way up to the application layer. So a customer can just download that and run an accelerated app on an accelerated platform on an accelerated operating system.
Great. And for Intel also, you have provided to market some GPUs. Also, after the acquisition of Habana, you are also providing HPUs. So could you also explain the collaboration on what OpenShift user can consume with your accelerators?
Yeah, absolutely. Thank you, Erwan. Actually, we are on a weekly call working on OpenShift in some ways or other. Firstly, Intel and Red Hat have been working with each other probably for 3 decades now, right, across the entire Intel's portfolio. So when you look at AI, we look at AI as a full platform from one end of the spectrum, which is our Gaudi accelerators, right, specifically for deep learning. But also looking at the other accelerators in our CPU also, we have AI accelerators. We actually do enormous amount of enabling on that. And also in, the edge accelerators as well, right? We have platforms at the edge, like the smaller compute devices, as well as our GPUs that actually are focused on the edge. So our integration with OpenShift is the full kind of platform view of it, from all of those pieces having that consistent layer that OpenShift provides and integrating with that. So that's kind of at the hardware layer, right? Now, to do that, we do a number of things, right? We actually, Adam brought up the whole DRA, right? How do you dynamically allocate resources? Definitely is one part of it. We have operators, essentially, that enable our accelerators on OpenShift. So it's very easy for customers to consume it. It's really an out-of-the-box experience that you'll get. When you get into OpenShift, and more specifically OpenShift AI, it's essentially fairly well integrated, and you're able to consume it. You see all the different hardware choices, depending on what your hardware platform provides. And it's a fairly easy selection process from there. Now, going one level higher than that is our software layer, right? All the different software pieces that are required for it, right? Essentially, our software on what we call One API is our software platform. We also have something called AI Studio, which is actually a way of doing an end-to-end data science platform as well. And our edge platform for our edge AI kind of inferencing, right, with OpenVINO. These are all the different kind of elements of software that we integrate as well. Now, even going beyond that, the two more important parts here is the whole security aspect, right? So confidential computing is a key part of this. So what we also do is really integrate our confidential computing in Intel technology called Trust Domain Extensions, or TDX. We've integrated that as well. So now when you deploy your models at edge, you're able to deploy that securely. So we've actually done that. And lastly, I would say even sustainability, which is, right, we all know the amount of energy that these compute devices take. So we have, we're actively working on integrating, essentially surfacing out all those power metrics into the OpenShift platform, so that you have a full view of what the compute devices are really taking and using, right? And then hopefully in the future optimizing, for power saving as well. So it's a full stack integration from a hardware, software, and all the other kind of pieces that go along with it.
Good. And so for AMD, you have provided to market new accelerators, so MI210, MI300X, and also in AMD it's not only GPUs, but Sam, you are collaborating with OpenShift on providing.
That's right. First, on the CPU side, we've been same thing working for many years. We have EPIC is certified OpenShift, and on the accelerator side, we've been working with you. Actually, your team helped develop the GPU operator, and we do have ROCm support also in Fedora. It's going to come to Red Hat. And all of this is going to go GA in a few months, but it's already used today by some of our common enterprise and defense customers. And in general, what we're doing is integration with the entire stack, optimization to get the best possible performance, and support. So we're working obviously on documentation for self-help and putting together a support structure for enterprise customers.
Good. So I don't know if all of you have joined this session tomorrow with Chris Wright, where Chris was explaining how open source can unlock AI. And also we are working all together, and it's a community day today. And it's all of you are contributing a lot in open source. So I would like to understand what are the challenges with open source, and also specifically for the OpenShift Commons in CNCF with Kubernetes, also how open source can help AI. We have seen recently a lot of new groups created in CNCF, so a group for cloud native AI, a new group for device management, a third group on serving, another one on batch. So like Kubernetes now is trying to fill a gap between the standard applications on AI application with specific requirements. So for open source, Raghu, if you can start speaking of at all the stacks on all the layers. We spoke like the drivers. So do you see some challenges? Are you fully involved in open source?
Yeah, absolutely. Thanks for the question again. Yeah, so Intel at its heart is an open source company from a software enabling perspective. It's really open source first. That's our strategy, right? So in terms of, specifically for the AI kind of segment here, right, the key challenge we see with open source is just this pace of these accelerators coming to the market, right, across all the different vendors is really rapid. And open source, as folks who have worked in open source know this, it takes time to get our stuff into the open source ecosystem. And that's one challenge that we really have, and that's why I like the whole operator model. It makes it easy and rapid for us to go consume and making our hardware available on these platforms. So, I'm hoping we'll come up with a better solution as time passes, but that's really a core pain point, right? Just the time and the effort it takes to do that. Now, specifically on the OpenShift AI, or more broadly the OpenShift side of it, right? The key challenges that we are tackling right now is definitely the whole dynamic resource allocation piece. How do you take a piece of hardware or device and allocate it amongst multiple containers or multiple pods, right? How do you do that? How do you manage the life cycle of that? That is a challenging problem. We definitely are actively working on, I would say that's one aspect. The other aspect is really to figure out from a sustainability perspective as well, right? How do you kind of both space shift and I would say time shift and orchestrate your workloads in a way that makes it easy for you to deploy at scale but still be sustainable. That's another big problem. I think we're starting points of working on that. Yeah, I would say just leave it at that for time reasons.
Yeah, Adam, you were speaking also of DRS, so same question on NVIDIA also has open source recently the CUDA driver. So yeah, you are also using all of these open source projects. So are you contributing, and what is your view on challenges?
So we're contributing to a lot, and a lot of us, our companies work together on a lot of these things in CNCF and other projects. I'd say there's two classes of problems that I see. There's problems with the stuff we have, and there's problems with the stuff we don't have. So with the stuff we have, there's a lot of it. It's coming out very fast. I think all of this generative AI stuff has been hitting us all very quickly, and we're pushing out new optimizers and new scheduling agents and all of these new features in the hardware and the software layer, and they're coming from the drivers and the platform enablement with all of these different operators and the application layer and K-serve and all of these different things. So packaging all of these things that come out every month into one application. We're not talking about traditional applications. These AI accelerated applications, it needs to be optimized full stack, and getting all of those moving components together into one thing is very difficult. The other thing is how do you actually manage that? So you talked about effective resource usage. How scheduling is a big problem. Getting access to all of these different clusters. There's a lot of these new working groups that are coming up, and we're trying to work on standards for deploying these applications, for monitoring these applications, because right now there aren't really any standards because we're in a very immature state for a lot of these AI workloads. And so we're getting there as a community, but right now there's no one way to do anything, so there's about 20 ways to do all of the things. So we need to close these feature gaps to make AI more effective and easier to use, and then we need to package it up.
On Ramine, so you have also a lot of contribution at the driver level with Roane, and also you're a strong contributor.
That's right, and what I see is that the challenge really is the difficulty to integrate different pieces of open source software and cloud native development together. Basically, compatibility is a problem, not just version compatibility, but also compatibility between different data format, OS, file system, and so on. And that's where Red Hat comes in, right, to put everything together and create an enterprise, rugged solution. And also the lack of standard is a problem. Raghu was mentioning that there are a lot of hardware companies that try to, or hardware startup that try to come up with accelerator, but really their only problem is software. And very, very few companies have managed to crack that nut. And it becomes exponentially more difficult when you have so many frameworks, so many formats, so many internal IR and offsets, and so on and so on. It becomes almost impossible for new players to invest as much as they should to get the software going. So I think over time, with maybe coming up with some standards and with the help of companies like Red Hat to try to create really targeted solution for enterprise, we can get there.
We can keep the mic. So this session is also about vision, on about the future. So AI is everywhere. On the hardware is really required for everything Gen AI, from both training, fine-tuning, and for a lot of influence. So for the future, Ramine, how do you see? So also I have heard you speaking of AI, on the case for the other, AI creating new chips, or AI generating, helping for the chip design. So how do you see the future? What you will provide to also help the users on to drive more AI?
Yeah, I think what we will see is that there's going to be more specialized hardware for specific workloads, like specialized accelerator for inference versus training, but also for LLM versus recommender system versus computer vision, and so on. And yes, you're right. I think definitely AI is helping creating AI faster and better. EDA is infused with AI, and EDA is used by us all to create the AI hardware, AI accelerators. So I see specialization coming, and the MI300X, for example, is specialized for inference of LLMs. And I also see more open source software development from hardware vendor. Intel is actually indeed really good at that, and NVIDIA, some yes, some no, and we're trying to go open source as well. We put Roane in the Linux Foundation in PyTorch. The sources are there. It's actually in the CUDA namespace. But yeah, those are the things I see: specialization, AI creating AI, and open source software.
And for NVIDIA also, are you doing inception to generate AI? And how do you see what you will provide to the market for acceleration for the future?
Yeah, so of course, I think we're going to keep seeing what we've been seeing is some bigger chips, faster interconnects, some more specialized features for LLMs or whatever the next workload. But one of the trends that I've been seeing is we're past the point where accelerators and GPUs are a one-off. They're now the de facto, and so we need to move to production in a way that supports that. So I've seen data centers dedicated to AI with specific build-outs for AI, but then also now the software, the tooling. How do we build resilient clusters so that if a single GPU or a single socket goes out, the entire optimized stack doesn't fall off? So I see a lot of work around the open source standards, right? We just started a new serving working group with Red Hat and NVIDIA, and Google leading that. They're working on standards right now for inference, standards for observability of LLMs, and I see that sort of thing happening in the SRE space and in a lot of the other spaces. And I think a year from now, we might start seeing a standard that we can all start to adopt so that these platforms roll out a lot faster.
And there are even standards being built for scale-out, like Ultra Ethernet, for example.
Good. And for Intel, you have announced new hardware coming. You are also investing.
Yeah. Looks like we're out of time, but I'll just make this one quick point. From an Intel perspective, right? Again, we look at this holistically, end to end, and the accelerations are going to be very different at the data center. Absolutely, right? Very, more and more specialized hardware. But as you kind of go and looking at the inferencing and fine-tuning markets, you'll see different types of hardware in those segments as well, right? So it's really looking at AI not just from one side of the spectrum, but kind of looking at it holistically is kind of the perspective that Intel has at this point in time. So I'll stop with that. Thanks.
Oh, we have again 20 seconds. I have used that. He's trying to cheat. Okay.
There's a flashing red sign saying stop.
Okay, but it was the last question. So thank you very much to have joined this session. And also for you, if you want to test any of these accelerators, you just need to launch your OpenShift. Go to the catalog. For all of these accelerators, you just type NVIDIA, AMD, Intel, and you can try. So on everywhere, so it's hybrid cloud, so you can just take a VM in the cloud, or if you have some accelerator on premise, it's working. So thank you.
Thank you.
Thank you.